Okay, we're in section 2 of the notes. This is the graphing of the trigonometric functions. Hopefully you paid attention during lecture and that you're understood what was presented to you. I'm not going to say completely, but enough that we can start to work examples. All right, so we went through the, some of the graphing techniques that we'd like you to follow. We talked about the sine function. This is the parent sine function. It's important you have this thing covered. All right. We talked about the cosine. This is the parent cosine function. Again, it's important that you have that covered as well. It's important you also know about the graph of the tangent function, the graph of the cotangent function, the graph of the secant function, and the graph of the cosecant function. We did talk a little bit about using calculators. For the most part, our graphs are going to be done by hand. All right. Some of the conventions that we have, I want to point out the ones that we're going to focus on is amplitude and the period of these periodic functions. Right, phase shift, sometimes hard to detect. I'm not going to say it's terribly important at this point, but the bottom line of waves can be shifted around left or right. All right. So the what we're doing over here is we're going to go the examples now. And of course, once we do the examples, then there's going to be a chance for you to try these on your own. As I go through the examples, though, please feel free to try on your own as I'm working through these things. All right. I should go slow enough where some of you guys can actually benefit by trying it on your own. All right. So I'm going to switch screens. Give me 1 second to do so. Okay, again, we're doing the examples. So section 2.5, the notes. The first, if you look at the first question, it says graph at least 2 cycles and find the period and amplitude. All right. This can be a consistent theme throughout this problem set. We want you to graph 2 cycles down, and then we want you to also determine what the period and the amplitude of that graph is. All right. Let's take a look at number 1. I'm going to go look at the picture later, but right now, just looking at number 1, what I recommend you do is, this beginning and end technique that we discussed. Right, so I'm going to write this down, begin. Again, we're doing number 1. And it begins where this argument, and again, we're doing this graph over here. It begins when the argument x over 3 is equal to 0. And that's fairly simple. I mean, x equals 0. And it ends, again, when the argument x over 3, well, for the sine function, the parent ends at 2 pi for a cycle. What does this give you? X would be 6 pi. All right. I would recommend putting a table down, x and y, and there's going to be 5 key points. All right, let's talk about those key points. So, first one I'm going to say x is 0. Right, now someone says, I don't know what the other ones are going to be. Well, I know what the end is going to be. And if there's 5 points, that means there's 3 in the middle. And what's the end going to be? 6 pi. You should be able to get a center between 0 and 6 pi, add them together. 0 plus 6 pi would be 6 pi, and 6 divided by 2 is 3 pi. All right. Next thing I would do is, what's the dead center between 0 and 3 pi? We'll add those two numbers together, and you would get 3 pi, and then divide by 2 to get the average, 3 pi over 2. Average is going to be the center. All right, what's the next one going to be? Well, the center between 3 pi and 6 pi, add them together, that's 9 pi. And 9 pi divided by 2 is 9 pi divided by 2. Okay, now I'm going to write this a little bit differently. I am going to erase that table. And the reason why I want to point out that I'm going to have to start counting. And if I'm counting this thing, I'm going to say it's really counting by half pies. So I'm going to say 0, 3 halves of a pi. Now, if you're counting by 3 halves of a pi, what's the next one going to be? 6 pi over 2. I'll write that down for you. I hope you realize that's 3 pi. All right. Now, of course, students ask me, do I need to do that? No, but you need to be able to count to the next point. What's the next point going to be? Well, I'm counting by 3 pi over 2. That's going to be 9 pi over 2. Now, let's take a look. If you keep counting by 3 pi over 2, that would be 12 pi over 2. That certainly gives me 6 pi. Let me just get my eraser out. I'm going to start to erase this business over here. And I want to continue to count. All right, I want to continue to count. All right, let's keep going. All right, my pen out again. And that's going to be what? If I'm doing 3 pi over 2, that's going to be 15 pi over 2. Now, what's nice about counting, you can count all day long with this. All right, 18 pi over 2. 21 pi over 2. Now, I'm getting kind of tired of counting. I want to start computing the y's. And as I do that, I want to point out where we're plugging it in. We're plugging it in to the actual function itself. So if you were to plug it in, what would you get? Let's take a look. You would get equals, I'll write this down carefully for you, minus 2 sine, well, 0 divided by 3 is just 0. And the sine of 0 is 0. And minus 2 times 0 is 0. That's fairly simple. Minus 2, we're doing the next one now, sine. Now, if it's 3 pi over 2 and I divide by 3, I would get pi over 2. No surprise there. The sine of pi over 2 is 1, and minus 2 times 1 is minus 2. Let's do the next one, minus 2 sine. 6 pi over 2 divided by 3 would be pi. Again, you have to do simple arithmetic, but it really turns out to be very nice numbers. The sine of pi is 0, and minus 2 times 0 is 0. I think you get the idea that this should be a very simple computation. What do you get over here? 3 pi over 2. What does that give you? Well, minus 1, and minus 2 times minus 1 is going to be 2. Well, we're really back at the beginning now. When I say that, the cycle ends, beginning and end. All right, and I put, that would be 12 pi over 2 divided by 3, which would be 2 pi. Again, no surprise here. That's going to be 0. Now, I'm going to take what I'm seeing the pattern over and over again. 0, minus 2, 0, 2, 0. Well, let's continue. Minus 2, 0, 2, and then if one here, it would be 0. Again, I'm going to see the same pattern over again. 0, minus 2, 0, 2, 0. All right, let's put another point down. I get 3 pi over 2, right? So it's going to be what? 24 pi over 2. I want to get my eraser out. And I got my table down. I'm going to erase all this business over here. Someone says, why are you erasing it? At some point, you could probably do that in your head. That's going to take time and effort on your part, though. And what I mean by that, you got to practice. That's a weak link for a lot of students, is the practicing skill. All right. So let's talk about the cycle length and the period of it. All right. So I'm going to point out to get the period. What you're doing is this is the begin, this is the end. What's the distance there? Well, let me write this down for you. It would be 6 pi minus 0, which would be 6 pi. This is the period. We'll look at the key later. I want to talk about the amplitude, and the amplitude is going to be, you have to understand this thing is going up and then it's going back down. And what's the most it could be? Well, I'm looking at my table. This is the y values. The most it could be is 2. What's the least it could be is minus 2. Well, I hope you realize the distance between those two is 4. What's half of that? 2. So half of 4 is 2. 2 is going to be the amplitude. Right. Let's look at our K. I want to point out it's important you start looking at the K. And again, I know there's a graph. I'll get to the graph later. 0, 0. I see that point. 3 pi over 2 minus 2. I see that point. 3 pi 0. I see that point. Now someone can say, oh, you have 6 pi over 2. That's 3 pi, right? I see this point over here, which is 9 pi over 2, comma 2. And then I see this thing over here, which they say is 6 pi 0. And I have 12 pi over 2. It's still 6 pi. What do they say? They say the period. Again, I want to point this out to you. The period's written here, 6 pi. The amplitude is 2. Now someone could say, how could you graph that? And I'm going to just talk about that briefly. We'll look at a better graph. But if I were to graph this out, I know it looks like the sine function. And what I would do is just kind of put down, an axis over here. I'm not expecting, like perfect graphs. We'll talk about what a perfect graph looks like later, flipping the page. I'm going to plot the points down for you. So I'm going to put 0 down here. That's this point here, 0, 0, origin. And I'm going to talk about, the ending of it, which is really 6 pi. And someone says, what's 6 pi? And 6 pi is, if you thought about it, pi roughly 3, 18. And someone says, well, you're not counting. Well, you're right about that. I'm not counting. But that's over here. I'm going to write this down as 6 pi. Right? It's a point. And this point over here is 0. Now, what's the point? 0, 0. And this point's going to be 6 pi, comma 0. All right, put my point over here. And again, I want to point out what we're doing over here. Just doing a point by point. I did this one. I'm going to do this one now. What's that guy going to be? 3 pi over 2, comma 0. Well, that's pretty simple right there. I'll write that down for you. And again, that's 6 pi over 2, which is 3 pi. That's the x-axis. What's the point? 3 pi, comma 0. All right, I got some other points to do. And, certainly I'm going to put them down for you. What is it going to be? It's 3 pi over 2, comma minus 2. Well, that's dead center. And minus 2, for sake of argument, I'll put minus 2 over here. All right? And again, this is going to be 3 pi over 2. What goes over here? 3 pi over 2, comma minus 2. What's the next point I would put down? Well, that's 9 pi over 2, right? That's dead center here, right? I'll write that down for you. And what does it go up to? It goes up to 2. Well, that's minus 2. I guess this would be 2 up here about, right? I'll put the point down for you. And what's that point going to be? Well, 9 pi over 2, comma 2. I'm going to draw my picture in of what I want a sine function to look like. And again, it's not have to be perfect, but it should look sort of like a sine function. But remember this, they said draw 2 cycles down. All right, so I want to do that for you. But once I have 1 cycle down, I think I could draw 2 cycle down just by continuing it. I'm not saying it's perfect. Let's put the points down now. All right, this is why it's so important you have a table down, right? But you can count here. I'm going to start putting these points down for you. What's this point over here? I'm just looking at my table. It's 15 pi over 2, comma minus 2. What's this point? 18 pi over 2, comma 0. What's this point? 21 pi. Whoops. I didn't put the 21 down pretty good, did I? Let me go backwards on that. 21 pi over 2, comma 0. And last but not least, we have 24 pi. Well, did it again, didn't I? All right, all those things are listed out for you. You got 2 cycles there. All right, we'll look at the better pictures later, by the way. And I want to encourage you that you really should be looking at better pictures. All right, let's do the next one. And again, as I do these things over here, again, if you think you're capable of doing it on your own, we certainly want to encourage that. And I'm going to do number 2 now. All right, so number 2. Still going to do begin. Well, cosine curve, 2x minus pi over 2 equals 0. The end of it would be where 2x minus pi over 2 is equal to 2 pi. All right, so I'm going to see if I can solve that for x. What do you get there? You get pi over 2, add 2 pi over 2 both sides. X equals pi over 4. Oh, this is going to be more difficult, right? 2x minus pi over 2. This would be 4 pi over 2. 2x equals 5 pi over 2. Yeah, you need to know basic algebra. And x would equal to, whoops, I made a mistake there. My eraser out. Again, when you add pi over 2 to 4 pi over 2, you get 5 pi over 2. Now divide through by 2, what do you get? You would get 5 pi over 4. All right. So it really the same thing over and over again. What I'm doing, I'm put a table down. X and Y. All right. right? So first point, pi over 4. And 5 pi over 4, right? Okay. To get the center, what you have to do is add those two numbers together. So that would be, let's see, 6 pi over 4, and divide by 2, you would get 3 pi over 4. Okay. Then what are you going to do? Add those two numbers together. That's going to be 4 pi over 4, and divide by 2. What do you get? 2 pi over 4. All right, now let's get the other, center. That's 3 pi over 4 plus 5 pi. That's 8 pi over 4. And divide by 2, you get 4 pi over 4. And I realize the tendency of some students, they want to reduce those numbers. I'm not opposed to it, but I'm seeing that as a counting problem now. And what do I mean by that? Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. I could count this forever. I really mean that too. 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4. And I think you get the idea. This could go on forever. I don't want to go on forever though. What I want to start doing is actually doing the computation. And the computation is really going to turn out to be pretty easy. And someone says, what is a computation? I'll write it down for you. And I'm going to circle it for you. It's really just a very simple problem over here. It's this thing over here. And I'm pretty much convinced that that's not too bad to do. It's minus 2 cosine. I'll write this down for you. All right. Again, I want to point out the arguments, 2x minus pi over 2. Again, I hate to bore you with the details, but you should be able to do simple arithmetic, and that would give you 0. Again, we're plugging it into 2x minus pi over 2. It's going to be minus 2 cosine, minus 2 cosine, very simple. All right, let's just go to the next one. Next one's going to be, if you did that, that would be, let's see, 2 pi times 2, that would be pi over 2. If you put 3 pi over 4 there, you'd get 3 pi over 2 minus pi over 2, which would be 2 pi over 2, which is pi. Really simple arithmetic for the most part. The next one turns out to be 3 pi over 2. And the next one's going to turn out to be 2 pi. This is so typical that we get these numbers over and over again. 0, pi over 2, pi, 3 pi over 2, 2 pi. Why is that? They're really the key features of the curve. What's cosine of 0? It's 1. So this will give me minus 2. What's the cosine of pi over 2 is 0, and minus 2 times 0 is 0. The cosine of pi, again, you'd have to know these things. If you don't know these, it's real hard to do. That's going to be minus 1. Minus 2 times minus 1 is plus 2. And then what do you get? Cosine 3 pi over 2, which is 0. Minus 2 times 0 is 0. Cosine 2 pi is 1. And minus 2 times 1 is going to be minus 2. I hope you realize I'm back in the same old pattern problem. And, what's the pattern going to be? I'll point it out to you. Minus 2, we're back at the beginning. Then it goes 0, 2, 0, minus 2. Let's put that down. Right? You keep doing this over and over again. Very simple pattern. Right? 0, 2, 0, minus 2, 0. Over and over again. Right? Let's talk about period. We'll look at the key later. What's the period going to be? Well, I hope you remember it's going to be the ending of it, which is 5 pi over 4, upper. This is the upper part, minus the lower, pi over 4. And what would that give me? 4 pi over 4, which is just simply pi. All right, what's the amplitude? Well, again, I want to point out that the most it appears to be in the y direction is just the number 2, right? So y equals 2. And the least is minus 2. What's the distance between those two? 4. What's half that distance? 2. So the amplitude is 2, right? I'm just going to briefly look back over the key. And I want to see if I'm seeing those answers. So I said the period's 2 and I said the period is pi and the amplitude is 2. I'm seeing that. Right. Let's see if we're seeing the points I said I'm going to say. Pi over 4 minus 2. I'm seeing it. Pi over 2, 0. That's actually pi over 2, by the way. 3 pi over 4, 2. Again, I'm just checking. Pi 0. This is actually pi 0. Again, I'm reducing in the k. And 5 pi over 4 minus 2. All right, I'm going to graph it. And again, I'm not looking for, great graphs, but we do provide better looking graphs for you. How am I going to do this? Number lines go down, x and y's. And let's take a look. So let's take a look at this. And the first point I'm going to put down is pi over 4 minus 2. And pi over 4, I'm going to say it's like over here somewhere. All right. And then if you thought about it, that's pi over 4. This is 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. All right, so I'm making a scale of pi over 4. And what's pi over 4? About 3/4. So I'm going to say minus 2 is here, and 2 is up here. All right, that would be perfect. All right, so pi over 4 minus 2. That's done. All right, now let's go to 2 pi over 4 comma 0. Now, if I'm counting by the same things, it'll be really easy to space these things out. 3 pi over 4 comma 2. 4 pi over 4 comma 0. 5 pi over 4 minus 2. I'm going to draw a little picture of what cosine curve might look like here. I want to draw 2 cycles. So I'm thinking I can probably do it pretty easily just by going in either left or right direction. If I did this over here, whoops, get my blue pen out. I think I know that point, right? Let's go to the next one. Next one's going to be over here somewhere. Whoops. I'm going to just trace out. Put the next point down. It's over here somewhere. And I put the next point down over here somewhere. And I'm going to start writing the points down. Now I got 2 cycles there, by the way. All right. So point, whoops, point, 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 point. All right, first point, 0, 0. Second point, pi over 4, comma, minus 2. This point, which is my third point, that's going to be 2 pi over 4, comma 0. All right, it's coming from the table. Next point, 3 pi over 4, comma 2. Next point, 4 pi over 4, comma 0. Next point, 5 pi over 4, comma minus 2. Next point, 6 pi over 4, comma 0. All right, and I'm just counting. That's all I'm doing. What's this point over here? 6, 7 pi over 4, comma 2. Whoops. This point, 8 pi over 4, comma 2. I'm sorry, comma 0. Sorry about that. All right, let's go to the next page. We're done with that one over there. And I want to point out there's better pictures provided for you. I don't mind students using these pictures. What I mean by that is using these pictures to label the points. For example, you should be able to label these points over here with the points that we had last time. And you'll see me do that sometimes. All right. I do want to point out, if you look at these things, look at the scale here. That's 0, that's 40. If you look at the scale over here, oops, let me go back to that. This is a much compact scale. It starts at 0, and then it looks like it's going around about 6 over here. All right, a little different. All right, let's go to the next page. And I'm going to be looking at number 3 now. Let's take a look at it. Blow this thing up a little bit for you. And you know me, I'm going to do beginning and end. All right, I'm going to do my little table down first. And I got a graph right in front of me. I'm going to just show you that maybe I should just use that graph, right? It's a good looking graph. I'm hoping it's a correct graph. And it's, you know, the figure they want me to do. Let's put this down. So begin. And that's going to be 2 pi x minus pi over 4 equals 0. And I'm going to do an end for that. Oops. And let's see, 2 pi x minus pi over 4 equals 2 pi. Let's see what we get over here. 2 pi x equals pi over 4. Well, I guess I would divide through by 2 pi. And again, you need to be able to do basic things like basic algebra. This should give me 1/8. And what's this going to be? More complicated, isn't it? 2 pi x equals, this would be 8 pi over 4 plus pi over 4. 8 pi over 4 is just 2 pi. So you get 2 pi x equals 9 pi over 4. Divide through by 2 pi. You can get 9/8. All right. So we get a beginning and end. Let's talk about the period. Upper, 9/8, minus lower, 1/8 is the distance. And that'll be 8/8, which is just 1. So the period's 1. We'll check with the key later. I can't do the amplitude yet. Well, I can, but I'm not going to do it yet. What I want to start doing is just a table. All right. And it basically, can I count it? I'll put this down. We got x and we got y. And I'm going to begin it somewhere, right? Pi over 4. I'm sorry, 1/8. And it's going to end at 9/8, right? So important we can count. Well, let's get the center for that. Well, if you add those two together, you get 10/8. And the dead center would be 5/8. All right. Now, if I did the dead center between 1/8 and 5/8, you add them together, 6/8, divide by 2, that would be 3/8. So it looks like I'm counting by 2/8. You know, 1/8, 3/8, 5/8, 7/8, and 9/8. Works out pretty nicely. And someone said, could you count that forever? I could, just by adding 2/8, 11/8, 13/8, 15/8. I think you get the idea that this could be gone. You could do this forever and ever and ever, counting it by 2/8. Now, so what do you want to do now? You know, basically what I want to do is I want to basically find out what y is, and it should be fairly easy, and there should be a pattern to that as well. Let's write it down for you. Equals minus 2 plus 3 times the sine of something. All right, now if you plug in 1/8 there, you know, what are you going to get? Well, you're going to get 0. Minus 2 plus 3 sine. If you plug in 3/8, I want to point out where we're plugging in. We're plugging in here. If you plug that in, you can get pi over 2. Minus 2 plus 3 sine, well, it's going to give you pi if you plug that in. Minus 2 plus 3 sine, 3 pi over 2. Yeah, fairly easy numbers to compute with, by the way. Minus 2 plus 3 sine 2 pi. Let's take a look at that. The sine of 0 is 0, and 3 times 0 is 0, so it's going to be minus 2. And then what do you get? Well, sine of pi over 2 is 1, and 3 times 1 is 3, and 3 plus minus 2 is 1. All right, now if you did sine of pi, that would be minus 1. 3 times minus 1 is minus 3, and minus 3 minus 2 is minus 5. All right, sine of 3 pi over 2 is going to be 1. and 3 times 1 is 3, and 3 minus 2 is 1. All right. Oh, gee, the sine of 2 pi is 0. 3 times 0 is 0, so you get minus 2. So I want to point out we're definitely seeing a repeating pattern over here. Begins at minus 2, ends at minus 2. What goes in center? 1, minus 5, and 1. Put that down for you. We'll check it with our picture too. Okay. Now, what I want to do is I want to just briefly go to the key. Oh, I can do the amplitude now. I'm sorry. So what's the highest? What's the highest it can go? Y equals what? Let's take a look at it. Looks like 1. And what's the least it could be? Looks like minus 5. What's the difference between those two numbers? 6. So the amplitude's half of that is going to be 3. All right, let's look at our K, and we'll talk about the graph later. All right, period is 1. I have that covered. Amplitude is 3. We have that covered. Let's see if we have the points down. 1/8 minus 2. 3/8 1. 5/8 minus 2. Whoops. 7/8 minus 5. I'm sorry. Ooh, I made a mistake. And I don't realize where did I make a mistake. Oh, I see it now. I see it. I made a mistake. Sorry about that. I got to correct it. And I really apologize for making a mistake. Let me erase this over here. All right, well, that business. I made a mistake somewhere. And I'm going to go erase it now. I guess I was daydreaming. Happens, right? Glad I got a key, though. And so I plugged in, let's see, 3/8. I got the 1. And the 5/8, I made a mistake over there. And the sine of pi is 0. And I put down minus, okay, I see it now. All right. And sine of 3 pi over 2 is going to be, I'm at 7/8 now, right? Is going to be minus 1. That's going to be minus 5. And then when I did sine of 2 pi, which is 0, that's going to be minus 2. All right. I did make a mistake. Like it begins minus 2, ends at minus 2. What's in the middle? 1 minus 2 minus 5. Ends at minus 2. All right. Let's go back to the key. 7/8 minus 5, got that. And 9/8 minus 2, I got this. All right. Amplitude, period, we got those as well. Let's take a look at the picture. And as I look at the picture, I want to point out I'm going to use it. And so we're going to look at those numbers. And the first number I want to point out to you is an ordered pair. And do this in red, this ordered pair over here. Now, the number that I find easier to deal with is actually the y number, which is minus 2. And I clearly see where minus 2 is. Where's 1/8 going to be? Right here. All right, so that's 1/8 on the x, minus 2 on the y. Let's do the next one. Of these two numbers, which one do I find easier? I find 1 to be easier. And I see 1 on the y-axis, right? And where would that be? Right up here. All right, we got that one covered. Let's do the next one. What's the next one going to be? Well, it goes back down to minus 2 again, and that would be 5/8. It's right over here. What's the next one going to be? 7/8 minus 5. It's right over here. Let's do the next number, 9/8 minus 2. 11/8 1. 13/8 minus 2. All right, 13/8 minus 2. 15/8 minus 5. And last but not least, I'll put the next one down. It's not in the picture. 17/8 minus 2, which is right over here. All right, let me just finish that curve out. All right, did I draw 2 cycles down? I'll point out what the 2 cycles I did draw down. I drew these 2 cycles down here. 1 cycle. 2 cycles. All right, what points did I use? The ones that are circled. All right, I guess I didn't circle the last one. Okay, let's go to the next one, which is, let's take a look. number 4. And I'll write this one down for you. Really not too bad to do. Beginning and ends, cosine function. And let's take a big N down. So pi minus 2x equals 0. I'll put the N down for this. Pi minus 2x equals 2 pi. And this can be pi equals 2x. If you can do this quickly, you certainly should do it quickly, by the way. This would be pi over 2. Let's see here, minus 2x equals pi, x equals minus pi over 2. All right, it may seem strange to you, but let's put this down. We'll talk about the points later that they're giving me. All right, so begins pi over 2, and it ends somewhere. What do you mean that one cycle? Now, it is going backwards, by the way, but that doesn't bother me at all. All right, so minus pi over 2. What's in this? I'm sorry. I'm thinking about something I shouldn't be thinking like that. Minus pi over 2. Well, if you add the beginning and end together, you get 0, and 0 divided by 2 is 0. That's not so bad. Now, if you add pi over 2 to 0, you get pi over 2, and if you divide by 2, you get pi over 4. Now, if you add minus pi over 2 to 0, you get minus pi over 2, and if you divide by 2, you get minus pi over 4. By the way, what I'm going to claim over here is it probably is a good idea to understand your counting. I'm going to say it looks like I'm counting by quarter pies. All right, let's see if I can write that down. 2 pi over 4 is the same thing as pi over 2. Right? The next one is going to be pi over 4. The next one is going to be 0 pi over 4. I'll just put down 0. Then minus pi over 4. Then minus 2 pi over 4, which I hope you realize is just simply minus pi over 2. Get my eraser out. And I think I can count that for a very, very long time. In either direction, by the way. Now, when I say that, I'm going to look at the picture, but the bottom line is that I could count those. What it may not be able to do is know what the y is until I look at it. Let's take a look at that. All right. So I'll write this over here. And what we're doing over here is this is going to be equal. Let me get my eraser out because I notice I'm taking up some space over here. I'm going to erase this business over here, my begin end. Let's write this down. Equals minus 3 cosine. Well, if you put that number in there, you would get, let's see, what would you get? You would get 0, which is great. Plus 2. Minus 3 cosine pi over 2 plus 2 minus 3 cosine. Let's see, that would give you pi. Just plugging it in. And you can do that. I'm sorry, 3 pi over 2. And this one going to be minus 3 cosine 2 pi plus 2. What's cosine of 0 is 1. So it's minus 3 plus 2, which is minus 1. We'll check these with the key later. Let's see, minus 3 cosine pi over 2 is 0. That's 2. That's not so bad. Cosine of pi is minus 1. That can be 3 plus 2, which is 5. Cosine of 3 pi over 2 is going to be 0, so it's going to be 2. And then what do you get? Cosine of 2 pi, which is 1, so minus 3 plus 2 is minus 1. And I'm definitely going back to the beginning. I want to look at the picture, though. I'm sorry. I want to look at my period and amplitude and things like that. I'll put a period down first. The beginning and end. So the beginning was, I erased that. I'll put this over here. Beginning was at 2 pi over 4, which is going to be pi over 2. And the end, if you remember, was minus pi over, let's see, that would be 2, right? Upper minus lower. I'll write that down for you. And the distance between those two is actually the absolute value of it. I'll put that down for you. So minus pi over 2 upper minus lower, pi over 2. And if you did that, you get minus 2 pi over 2, which just simply, minus 2 pi, minus pi. So absolute value minus pi is pi. So the period is pi. That's the distance between beginning and end of it. And the amplitude, what's the most it could be? I'm looking at it. It looks like 5, and the least it could be is minus 1. The distance between is 6, and half of 6 is going to be 3. All right, let's look at the key. And what I mean by the key, I'm looking at these points over here. Do I see this? Yes, I see it. 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 Next up, do I see this one over here, which is minus 2, minus 1? Yes. What they said the period is pi. I'm seeing it. And they said the amplitude is 3. Now, granted, I want to emphasize for a lot of students, graphing is difficult. And I really don't enjoy it myself. But the bottom line is you have to get sort of like a rough picture of it. They do give you a good picture, though. And that good picture is on the following page. All right. I'm going to go to that. And I'm going to start talking about the points on the following page. All right. And this is the page we're on here. And again, we're looking at this picture, and I want to point out what picture we're looking at. This picture over here, I want to be really careful about labeling this picture. All right. And someone says, I don't even remember what those points are. Hopefully you have the notes in front of you. And I want to point out the first point that I got. I'm going to make sure that we're on number 3, right? And let me make sure I'm looking at number 3 for you. I'm sorry, we're in number 4. What am I saying? So we're number 4, and I'm looking at the partial graph of number 4. All right. Now remember the points I got, and the points I got is the first point was pi over 2 minus 1. All right, pi over 2 minus 1. Now someone says, where is that? I'm going to say that's right here. I'm going to write that down for you. All right, what's the next point I got? You know what, pi over 2, yeah, that's not bad. Pi over 2 minus 1, I did that. Pi over 2 is about 1.5. And the next point I got was pi over 4, 2. Well, that's right here. Again, don't be intimidated by this. Okay, what's the next point I got? 0, 5. Okay. Now someone says, what's the next point? And I really don't have it down, but I can put it down for you. And that was minus pi over 4, comma 2. I got to extend this picture now, right? You can do that. Okay. What's the next point I got? Minus pi over 2 minus 1. I'm going to say it's over here somewhere. And I'll put this over here. Not perfect, right? I'm going to start putting out other points for you. What points you're going to, the points that I'm seeing in the picture. I see this. I don't have it labeled yet. I see this. I see this. And I see this. Here comes where counting comes in, really important. And I want to point out really counting by pi over 4. So, that's beginning. I just want to point out what I'm doing. Minus 2 pi over 4, minus 1 pi over 4, 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4. I'm going to write that down for you. 4 pi over 4, 5 pi over 4, 6 pi over 4. All right, let's put the other number down, the y number. 2, 5, yes, I'm looking at my picture, 2, minus 1, and we're done. Let's go to the next one, which is going to be a tangent function now, right? So a little more complicated, but yeah, certainly beginning and end of it, and you'd have to know about the parent tangent function, and we'll take a look at the picture. But right now, my understanding is like got to get the details down. And those details for me are going to be like the beginning and end of it. All right. So I'm just going to, maybe go to the picture, and the picture's on the next page. Let me do that for you, which is going to be minus 3 tan of 2x. All right. So I'm seeing that picture. And we put it on the side, and we're going to talk through it. All right. So first thing I'm going to do is begin and end. And I have y equals minus 3 times tan 2x, right? And we've talked about the parent. The parent begins at an asymptote, and that asymptote is minus pi over 2. And that means x equals minus pi over 4. Well, let's talk about an end of it. Y equals minus 3 tangent of 2x. And the parent ends at an asymptote, and that asymptote is going to be pi over 2. So it's going to be pi over 4 now. Okay, let me go to my picture. And I'm going to put those two lines in for you now. And I'm seeing them. And what about the first one I'm seeing is an asymptote here. I'm not saying I'm doing a terribly good job of it, but good enough for me. And let's write this down. And what's this line going to be? X equals minus pi over 4. And this one over here is going to be x equals pi over 4. All right, let me do my table now. Should be fairly simple to do. You should be catching on to this. I think you should anyway. X and y minus pi over 4 pi over 4. Dead center would be 0. The tangent is 0, 0, and minus 3 times 0, 0. That's fairly simple. All right, what's the dead center between minus pi over 4 and 0? Would be minus pi over 8. By the way, these are asymptotes. The asymptote is x equals minus pi over 4. And this asymptote over here is x equals pi over 4. So if you plug in minus pi over 8, you get, minus pi over 4. And the tangent of minus pi over 4 is minus 1. And minus 3 times minus 1 is plus 3. And dead center between 0 and pi over 4 is pi over 8. And, 2 times pi over 8 to pi over 4. 10 to the power of 4 is 1, so it's going to be minus 3. So we got 2 more points. Let's put them down for you. And 3 is easier for me than do minus pi over 8. I want to point out what I mean by that. This is 1, 2, 3. Let's say the point's right about there. And this point's right about, let's see, 1, 2, minus 3, right? All right. I want to encourage you to look at the answer key. And we only have one cycle down. I'll put another cycle down for you in a moment. But I want to make sure I'm seeing these points over here. And certainly, I want to encourage you to look at a key that's provided to you. All right, I'm going to kind of go through it. I'm looking at the key myself. And it says the period. I didn't put the period down. All right, the period. And if you look at the period of this thing over here, it's the distance between the beginning and end. And if you look at that, it's pi over 4 to minus pi over 4. That would be 2 pi over 4 is a distance there. So the period, again, the period's going to be the distance between pi over 4 and minus pi over 4, which is 2 pi over 4. And that's going to be pi over 2. It has no amplitude, though. There's no maximum. It goes on forever. Let me point that out to you. This graph is asymptotic, and it goes on forever. All right. Let's see if we got the points right, though. I'm going to start circling for you. Do I see that point? Yep. Do I see this point? Yes, I'm looking at the key, by the way. And do I see this point over here? Yep. All right, I'm going to put the other asymptotes in for you. And someone's having you do that. And I'm going to say it. I think I can count there. I'm going to put 2 cycles down for you. X equals. All right, let me point out what I'm doing again over here. There's distances here, right? And the distance between those two is actually 2 pi over 4. Right, that's the period, right? And 2 pi over 4 is just pi over 2. Now someone says, why are you saying 2 pi over 4? Because it's easier for me to add it. Now if this is pi over 4 and I go up 2 pi over 4, you'd be at 3 pi over 4. I'm going to put some points down here for you. And I'm going to label them. All right. So what I'm going to claim over here is that all we're doing is shifting over the period. And what's the period? Pi over 2. So what's this thing going to be over here? Pi over 2, comma 0. All right, this point might be more difficult. I still want to write it down for you. And this point might be more difficult. But what I do know is I do know that in these numbers over here, that this is going to be 3, just like the other one, and this will be minus 3. Now, my claim over here, what we're doing is we're just moving. That's all we're doing. So if we're here, that's this point over here, right? And we're going to move over. So how much move over? Pi over 2. All right, let me write that down for you. So minus pi over 8 plus the period, which is pi over 2. Right, common denominator would be 8 minus pi plus 4 pi, which would be 3 pi over 8. All right, let's do the next one. This point over here, and certainly, I know the y coordinate's minus 3 there, but it's pi over 8, and we moved over pi over 2. Right? Common denominator 8. This would be pi plus 4 pi, which would be 5 pi over 8. Basically a simple counting problem. All right, let's go to the next question. And again, when I do the next question, I want to point out, we're going to look at the picture. And next picture is this one over here, the cosecant. I'm going to actually use their picture. I like their picture. So let's talk about the beginning and end. Before I do that, though, I want to point out what I'm going to graph out here is not the cosecant function. I'm going to be graphing out, and I will erase it. We're going to be graphing out y equals minus 3 sine pi over 2. And then we'll talk about the reciprocal of it. All right, now how do we do that? What we're going to do is we are going to, well, let's see what we're going to do. Beginning and end. Whoops, I said pi over 2. I'm so sorry. Must be daydreaming. It's x over 2. I'm getting a little better at this. I put my little table down. Let's see, 0. Let's see, that would be 4 pi, right? 2 pi, 1 pi, 3 pi. Let's see, that would be 0, minus 3, 0, 3, 0. I'm going to draw that picture in now. And I'll erase it later, by the way. I'll do it in red. 0, 0. And then I would get pi minus 3. And pi minus 3 is over here about. And then I would get 2 pi 0. 2 pi 0 is over here about. And then I get 3 pi over 3. That's over here about. And then I get 4 pi 0. It's over here somewhere about. All right. And the sine function would look sort of like this. Whoops. Sort of like this. I certainly want to erase that, by the way. And someone says, why do you want to erase that? They asked me to graph, that's why. I'm going to put the point down that matches. And I'll put this one over here first. This is going to be pi, comma minus 3. And what's this point over here? Well, that's going to be 3 pi, comma 3. right? So I just plotted this point here and this point over here. There's trouble with these though. And what would I have over here? I'm actually doing the cosecant. So I'm really doing the reciprocals of zeros, which are going to give me asymptotes. All right, I'll put the asymptotes in now. Going to be one here. I'll write it down for you. And there's going to be one here. And again, I'll write that down for you. And there's going to be one over here. I'm now going to erase the sine function. This is so typical. And let me get my points down again for you. This is a really important point. That's a really important point. And I'm going to put the asymptotes down for you now. And they're really going to be very simple to put down. Hope you can remember we just did those. X equals 0. X equals, I want to tell you where they're coming from, here. X equals 2 pi. And what's this one over here going to be? X equals 4 pi. Whoops. Sorry about that. Okay. That looks like a really simple counting problem. So what's this one going to be over here? X equals minus 2 pi. What's this one going to be over here? X equals minus 4 pi. I can put some other points in for you. I think I can do it. I'm just looking at it. I got my numbers down. I know what they are. This is going to be what? Minus pi, comma 3. What's this one going to be over here? Let's see, just count it. It's going to be, let's see, 1, 2, 3 pi minus 3 pi. Oh, I did it again. Comma minus 3. All right. So let's talk about the period. The distance between beginning and end is 4 pi. No amplitude. This goes on forever. I'm going to point out what I mean by that. Again, reciprocal function. Okay. Look at the key. The key you're looking at, it says the period's 4 pi. I got this covered. It goes on about the 5 characteristic points and the 3 asymptotes, yada, yada, yada. We kind of graph that out. I'm looking at my key over here. I got the points labeled, which is, pi minus 3. Yep, I got that one down. Let's see. But yep, I have it down. Asymptote x equals 0. I have that one down. X equals 2 pi is an asymptote. 3 pi over 3. Yep, got that one, and 4 pi. And we have the picture, and the picture is provided to us. All right, so let's go to number, I guess we'll do number 7, right? And number 7, let me see if I can do that. Yeah, number 7's right here. We got the picture right in front of us. And getting a little better at this. So I'm going to begin end. I'm going to do the cosine curve. I'll write this one down for you. So we're really doing the cosine of 3 pi x. And 3 pi x equals 0. X equals 0. And the end of it, let's put this down, 3 pi x equals 2 pi. And that would be x equals, well, I divide through by, 3 pi. What would you get? Pi's disappear 2/3. All right, beginning and end. All right, let's put this down. And it should be really, really simple to put down. So if you're doing a cosine curve, the begin at 0, I got this. Where's 2/3? Right over here. Right? If you were to draw a picture of a cosine curve through that, it would look sort of like this over here. What are we doing now? We're not drawing cosine. We're drawing its reciprocal. And I'm going to say I got really nice points over here. Let me get my eraser out. I'm going to tell you what these points are. I can blow this up. Give me a second. And I'm going to really kind of focus in those 3 points now. All right. So I'm going to just talk about that. And this point over here, the first point I got, that's really simple, right? That's just going to be 0, comma 1. What's this point over here going to be? 2/3, comma 1. Now, what's the center between 0 and 2/3? It would be 1/3. I'm going to put my asymptotes in. Now, I know it's difficult. I don't want to go too crazy with it, though. They got to be symmetric, too, and dead center. And what's the center between 0 and 1/3? 1/6, right? Put that down. X equals 1/6. And what's the center between 1/3 and 2/3? Well, if you add those two numbers, you get 3/3, and divide by 2, you get a half. Not 0.5, right? Roughly right. All right, let's talk about the period. The period is the distance between the beginning and end. Well, 0 to 2/3, that's going to be 2/3. All right, relatively simple. There is no amplitude. All right, this goes on forever. I'm just putting this in for you. What I want to do is I want to get some more cycles going. And I think it's going to be pretty simple to do by looking at the picture. And you learn by looking at pictures, by the way. What's this aspect over here? X equals minus 1/6. All right, I'm going to put this asymptote in. What's this going to be? X equals minus 1/2. You may wonder where it's coming from just looking at the picture. I see these numbers. All right, put some other points down for you. I want to put this point over here. Perfect symmetry, right? For the most part, minus 1/3, comma minus 1. And let's put another point down. I guess I'll put the point over here. And what would that be? Let's see, minus 2/3, comma 1. I'm just looking at the picture. Let me kind of draw it in for you. And again, we could do this game all day long, including drawing down more asymptotes if we wanted to. Okay, I want to encourage you to look at the answer key. When you look at the answer key, make sure that when you're looking at them, you're agreeing with what we're giving you. And I put down, let me just pull this over here for 1 second. I did put down the asymptote of x equals minus 1/6, 0.01, we got that covered. X equals 1/6, I had that one covered. And 1/3 minus 1, I had that one covered. And x equals 1/2. And I got that one covered as well. All right, your characteristics. And again, these graphs are being formed by machines over here. All right, let me go to number 8. And number 8 is a cotangent function. I want to go to the next page, which is where I see the cotangent. And I'm going to go through the work. And I'll write it down for you. And the cotangent function, certainly beginning and end. And I'll write this one over here for you, begin. And the begin is when pi x over 3 equals 0. And it ends when pi x over 3 equals pi. So it's going to begin at 0, and it's going to end at 3. Right? Now, when I say beginning and end, that's where the asymptotes are. Let's put the asymptotes down now. And again, we're using the picture to help us learn. This is x equals 0. What's the next asymptote? X equals 3. Well, I bet right now that you could put down all the asymptotes. What are you doing? You're counting by 3. What's the next one going to be? X equals 6. What's the next one going to be? X equals 9. All right, getting better at this. Let's do some points down now. What's the center between those two numbers? 1.5. Right, that's right here. I'm going to put the point down for you. So the point would be 1.5, comma, 0. Okay, between 0 and 1.5, what number would you get? 0.75. So 0.75, if you plug it in, would evaluate to 1. Where's that? Over here somewhere. And then certainly I'm just looking at this and I'm looking at, between 1.5 and 3. Let's see, I guess you got to go, that'd be 2.25, right? Okay, look at the key. All right, what does the key say? Characteristics, asymptote x equals 0. Then you get a 0.75, which is 0.75, comma 1. I got that right over here. Next point would be 3/2 0. Again, putting in the fractions 3/2 0. 9/4, what's 9/4? That would be 2.25, comma minus 1. I got this. And the asymptote of being 3. All covered. Okay, so that's number, what was that number? That was number, I guess that was number 8, right? And then we're going to move on to number 9. All right, number 9 is in the following page. And I'll write it down for you. And I'm looking at this one over here. So number 9, this is 9, begin is when x equals, we're doing the cosine, by the way. And it ends when x equals 2 pi. All right, so let's put the points down. All right, so what's the first point going to be? Well, it's going to be beginning is 0 and the end at 2 pi. So I get this over here. Got these nice simple points over here. And we'll label them for you too. All right, put the points down for you. What's this point over here? 2 pi, comma, minus 3. This point over here is 0, minus 3. Now, what's the difference between 0 and 2 pi is pi? So this point over here would be pi, comma, 3. Let's put our asymptotes in. It should be really simple to do. I don't want it too crazy. It's just 2 cycles, right? Let me draw the picture. And I'll do these 2 over here. Oh boy, let's see this one over here too, right? All right, let's put the point down. Looking at it, actually with a picture couldn't be easier. What do we have here? Minus pi, comma, let's see what we get there. 3, right? All right, let's put our asymptotes down. We'll label them, right? And what's going to be pi over 2? X equals minus pi over 2. What's this one going to be? X equals, and I'm just looking at my picture now, and I hope you're looking at it as well. Just kind of counting, right? So you got x pi, I'm sorry, 0 pi over 2, pi, 3 pi over 2. And this would be x equals 4 pi over 2. Got that with the point? Yep, got that. And then there was going to be the next 5 pi over 2. All right, you can go on all day with this. Okay, let's talk about the what they're giving you in the notes. And it says over here, yeah, it doesn't really give you the answers over there. The question is, that wasn't their question. Their question was what? Determine whether the function is even, odd, or neither. Okay, look at it. Clearly, it is an even function. Now, why is that folding symmetry about the y-axis? All right, so the answer is they're even. I'm going to switch over to using software now. Just give me a moment. And we're going to do problem number 11 by switching screens. Okay, number 10. What does it say to do? It says use a graphing utility to graph each of the following functions. Right, so the first one says graph y equals the absolute value of x times the cosine of x. We'll do that in a second. The next one says graph x times the absolute value of cosine x. And then they said we'll get these pictures over here. Let's take a look at them. And I want to just briefly talk about Wolfram alpha. Right. The reason I want to talk about that, I think it's easy. I think it's the easiest for students to use. Right. So let me open up a web browser. And I'm going to put Wolfram alpha. Right. I'm on the page. And what I want to do is just briefly talk about doing these graphs. I'm going to type it in. I'm going to say graph. It's like using Google almost. Graph. The absolute value, ABS. Let me put y down, okay? Y equal the absolute value of x times the cosine of x. Let's see what happens. And I want to put on, I'm looking at a picture that I use different software to make this over here, but I'm seeing the picture. I want to see what Wolfram alpha does. And Wolfram alpha gives me this picture here, this is a close-up of it, and then something a little bit further away. I'm going to say relatively in agreement. All right, let me go to the next one. And the next one's going to be this guy over here. All right, so let's take a look at that. And the next one's going to be this guy right over here. And a little bit different. And I'm going to type it in for you. And this one is the absolute value of the cosine of x times x. And let's see if it gives me the same picture that I'm assuming you're going to get. Yeah, I'm seeing it. Same picture. All right. Learn to use software. Right. Really mean that. Okay. We're at the point now where someone can say, I can't do this. There's no way I can do what you just did. Of course you can. Right. So what you have to do is you have to do this now. You got to go back over and study what we presented to you. Now, granted, some things you might say to yourself, I'm not ready for it. Here's what you're ready for. You're ready to do simple things. Right. What do I mean by simple things? Starting somewhere. Make sure you review what we've presented to you, though. Right? Make sure you make sense out of that. Maybe you have to go to the YouTube videos, look at other people doing these problems over here. But you're at the point now where you should be saying to yourself, I wonder if I can do what I just did in front of you. I'm not saying you're ready for it yet, but you have to study more. But you should be able to be ready for supplemental activities. What does that mean? Could you do this one over here? Graph at least 2 cycles, determine the period and amplitude of it. What do? We give you a picture, and we give you the answer, right? Work through it. See how you do. Thank you.